So first look at loading values into registers. So both the A and the D register can act as data registers and be used to hold data values. So the easiest values to set them to are 0, 1 or -1, because these come directly from the ALU computation. So these are computations of ALU can do. Then we can just set the output, so the destination of the ALU operation, to be the particular register. So for these examples, we're just going to use this C instruction. We're going to set the destination equal to the required computation. So very simple examples: D equals 1, D equals 0, D equals -1. The same with the A register. It's very easy to load 0, 1 or -1 into either the D or the A register. So we can also use the RAM, so the memory. So this is where we use the M. So we can also use that to store data. But before writing data to RAM, we must select the address we want to store the data using the A instruction. So in this example, it actually takes 2 lines or 2 instructions here. So the first instruction is an A instruction. So this we're going to set the A register to be equal to 5. So then in the next instruction, when we do M equals 1, it'll actually store the value 1 in RAM 5. So whatever the value stored is in A, when you refer to N, that's the address that it'll store the data in. So you can set it, here we've set equal to 1 directly, or we could do -1 or 0 as we've seen before. But often we want to copy the contents of either D or A to a particular RAM location. So we do that pretty much in the same way. So first we set the address. So in the example, we'll set the address to 12, and then now we'll just do M equals D. So now that we're just going to do the D computation, whatever value is currently stored in D will then be copied to the 12th slot in RAM. So to store literal values in the D or A register, we need to do it a little bit differently, because we can't use 0, 1 or -1. So sorry, they're the only values we can do directly, because they correspond to ALU operations. But for any other value, we need to use an A instruction. So it's very, if you want to store the literal 99 in A, it's very simple, because we can load data values into A using this syntax. So at 99, we'll store the value 99 into A. And then you just have to use, if you want to store a literal value in D, you just have to use A as like a buffer type thing. So first, store the value in A, and then do D equals A. So whatever value is currently in A will be copied to D. So store literals in RAM. Now this actually takes up 4 instructions. So first, we need to store the value we want to. The value we want to store, the literal, we need to put in A. So we're going to load 57 in A, and then we'll copy that to the D register. So we'll basically use D again as a temporary buffer. And then we can set now so 10 is the memory address. So we're going to load the memory address into the A register, and then the 57 we stored previously in D, we can just copy to M. So to store literals in RAM takes these 4 instructions. We have to use the A register twice. We use it firstly to store the data, then copy it to D, what's it acting as a buffer, and then store the address where we want to store the value in A before using M equals D to copy that across.